Hey kids, Mr. Murray here, Mr. Murray's Mathland. Taking a look at graphing lines. We've done it by making a table, and we're doing it by another method here in this video, which is by finding the X and Y intercepts of the line. So notice here, here's the equation 8x minus 4y equals 24. You can just take my word for it, and the line has been drawn here on the graph. And first of all, let's talk about what a y-intercept and an x-intercept even is. So it says give the y-intercept, give the x-intercept. The y-intercept is just what it sounds like. You can think intercept means intersect. Where does the line hit the y-axis? And so here's your line. Here's your y-axis. Remember, that's the one that goes up and down. And where does it hit? Right here at this point. And so that point is 0. Never forget, this is a big part of what we're talking about today, that, the x value on the y-axis is always 0. It's maybe kind of obvious, but it's going to come in handy today with what we're talking about. So just keep that in mind. So the y-intercept is 0, -6. Or sometimes people just say -6 because it's kind of, understood and assumed that the x-coordinate has to be 0, so they just name the y-coordinate. No, the y-intercept is -6. Boom. That's totally fine to say it that way as well. I'm going to go out of my way to use the ordered pair today because that's going to help us find them in some of the problems we're doing. You're going to see in a minute. So x-intercept is kind of the opposite. Just where does the line hit the x-axis? Well, here's the line. Where does it hit the x-axis? Right here at 3. Or if I wanted to use an ordered pair, that would be 3, 0. And again, kind of the opposite is true, that when you're in x-intercept, the y value has to be 0. So you could say 3, 0, or you could just say 3, and people would know just what you were talking about. Oh, it hits the x-axis at 3. Boom. So that is going to be something we use in a minute, because I'm going to give you an equation and say, find the x-intercept, find the y-intercept. And how you find a y-intercept is you plug in 0 for the other coordinate, for the x-coordinate. And how you find an x-intercept, you'll plug in 0 for the other coordinate, for the y-coordinate. So here's what we mean by that. So we have this equation, and notice this is not solved for y. Y is not isolated, it's not all by itself in this equation. So making a table wouldn't be so great in this format right here. So one thing we could do is find the x and y intercepts, and you're going to see this technique here. And you could think of it like this, if you like. To find the y-intercept, I'm going to plug in 0 for x. And we just said that a minute ago, right? In order to be on the y-axis, my x-coordinate has to be 0. So I'm going to plug in 0 for x and see what comes out for y. And then I'm going to do the opposite. To find the x-coordinate, I'm going to plug in 0 for y and, find out, right? Because in order to be on the x-axis, my y-coordinate has to be 0. So here we go. There's 2 different points. That's the thing to keep in mind. And so just take your time here. My y-intercept, I'm going to put in 0 for x. You put in 0 for the other coordinate. And you're going to see how some of these can be really fast. You might even do them in your head. But I'm showing you all the work here just to try to show you where it's coming from. So I go to this equation, 3x plus 2y equals 12, and you put in 0 for x. And when you do 3 times 0, what do you get? 0. See, that part just drops out. Plugging in 0 is always easy to work with. And I have 2y equals 12, and just solve for y. Divide by 2, divide by 2. Y is equal to 6. So when x was 0, I got out 6 for y. Now let's get my x-intercept. Very similar. I'm going to go to that equation, 3x plus 2, but I'm going to put in 0 for y. And when you put in 0 for y, 2 times 0 is 0. That part just drops out. and you're left with 3x equals 12, and divide to solve for x. And you got x equals 4. So my x-intercept was 4, my y-intercept was 6. Just remember they are two different points. 0, 6, there's your y-intercept. 4, 0, there's your x-intercept. Plot that point, and then just connect them with the line. There's only one line that could possibly pass through those 2 points, right? There's only one way to connect them. And there you go. There's a little off there, but very good. So you see why plugging in 0 for the other coordinate can be pretty easy, because you can kind of just say, okay, when I plug in 0 for x, this part's going to go away, and I'm going to be left with 2y equals 12. Oh, just divide by 2. Y is 6. When you plug in 0 for y, this part just drops out. And solve for x by dividing by 3. So a lot of these things you can do mentally when you really get the hang of it, if you feel comfortable. But like always, just don't make any silly mistakes. So let's try another one here. Let's find the x and y intercepts, and then we'll plot them and connect them. Connect the dots, basically. So again, I'm going to put in 0 for x, see what I get out for y. I'm going to put in 0 for y and see what I get out for x. So I'm going to go to this, find the y-intercept, put in 0 for x, and see what we get out. When I put in 0 here, right, that part's just going to drop right out, and you're going to be left with negative y equals 4. So that just means you got to divide by negative 1. And y is equal to negative 4. There we go. To find my x-intercept, again, this might be something you can kind of just do in your head. To put x-intercept, I'm going to put in 0 for y, so you're going to be left with 4x equals 4, so x is going to be 1. You don't feel comfortable? Then write it out. But I'm going to put in 0 for the other variable. And we have 4x equals 4. Divide both sides by 4 to solve for x. X is equal to 1. So there's your 2 points here. 0, negative 4, 1, 0. So my y-intercept is 0, negative 4. Go to negative 4 on the y-axis, put a dot. 1, 0 is my x-intercept, so put a dot on 1 on the x-axis. And do your best to draw a nice straight line through them. Not like that. There we go. And as you know, whenever you're drawing your graph, extend your graphs all the way to the edge there. You know, I left a little bit there, but that's not too bad. But definitely don't just like connect the two and leave a little segment there in the middle. It's a line. It does go on forever in both directions. Some people feel you should put arrows on the end to show that it goes. You know, that's really not necessary in my book, but that's fine. And one more problem here. Notice this is isolated for y, this equation. So this would normally, if you gave me the choice of doing these two methods we've been working on lately, either making a table or using intercepts, I would usually make a table for this. But we did say to do it by finding intercepts, and you should be able to find the intercepts no matter what form it's in. So this is just good practice for that. So I'm going to put 0 in for x and solve for y, and then vice versa. So my y-intercept, I'm going to go to this equation, plug in 0 for the other variable. And when you do that, it kind of works out pretty nicely. Negative 2 times 0 is just 0, so I'm left with y equals 5. Yeah, nothing really to solve for there. Very nice. 0, 5. For your x-intercept, I'm going to put in 0 for y in the equation, right? 0 goes in for the other variable. And see, this is where it's a little more annoying. I now have to solve this equation. So I either have to move, the 5 to the other side by subtracting 5, or move the x's to the other side by adding 2x. I think I'll do that. I'll add 2x to both sides. And your new equation says 2x equals 5. And then divide both sides by 2. And you get x is equal to 5 halves, or 2.5 or 2.5. Not every intercept has to be a nice whole number, right? It can really cross the x-axis anywhere it wants. So here are those 2 points, 0, 5, and 2.5 comma 0. So you do your best to put it right perfectly between 2 and 3. That would be about 2.5. And there we go. And, just this having a decimal, a non-integer value for these shows the limits of, using intercepts. Sometimes it's not that accurate. What if they're both decimal values? And what if the decimal is not even a nice decimal like 0.5, but it's like, 0.62? So we're going to learn even better methods in the coming days of how to do these. But still, this is a pretty solid method. Plug in 0 for the other variable and get that point. Plot those 2 dots, connect the line, and that's it. So hopefully you have a good handle on finding intercepts. If you have any questions, just let me know.